Hello, everyone. Welcome to today's Tech Talk. My name is Amulya. I'm a Senior Solution Architect at AWS, and I help customers use AWS and also focus on open source observability as an observability specialist. Okay, so today's topic is open source observability with AWS, and I'm honored to be joined by Saurabh from Airbnb. On the first part of this talk, I'm going to talk to you about AWS managed open source services for observability. And in the second part of this talk, which is going to be more exciting, I'm going to have a Q&A with Saurabh. So let's get started. So when I started working, the world used to be very different. My application was running on a server, and I can log into it and do a tail -f system.log. And there I had all the logs I wanted. It was the word for monolith and very static architecture. But over time, the architectures have evolved. From monolith, we moved to static architectures where you have fleet of virtual machines running an application, and you have agents running on those virtual machines, collecting all the metrics and logs. And it was very limited scale. So it all worked fine. But we live in a very different world now. Today, with the rise of distributed systems like Kubernetes, visibility is even harder. Even though Kubernetes gives a lot of flexibility for scheduling, but it takes away the visibility we used to enjoy in the past. Serverless architectures like Lambda is another piece in the puzzle. Getting the logs from the function as a service is a must requirement you need to have. Lastly, the software as a service integration is another challenge for observability. The challenge is, let's say you are using a third-party payment processing and you send the transaction, you would want to make sure you have all the logs, latency, execution time captured in your observability toolkit. So sometimes it feels like debugging in today's world often is like finding a needle in a haystack. It is very hard and complex because of the distributed nature of our stack. But good news is that AWS offers you a wide variety of observability services. So this is our observability portfolio. On the left-hand side, we have native services like CloudWatch, CloudWatch Logs, and AWS X-Ray, along with Container Insight, Lambda Insights, etc. These are native to AWS services. On the right-hand side, we have open source managed services from AWS. This is where we've been very busy from last 1.5 years. And we had Elasticsearch for log aggregation for many years now, but in last 1.5 years, we have added Amazon Managed Service for Prometheus, Grafana, and AWS Distro for Open Telemetry. And we'll talk about all of these open source services as next section of this presentation. So let's dive deep right into it. So as I said, AWS is investing heavily on making open source observability services available to you as a managed service. Today, we have 4 selections. Amazon Elasticsearch service, which can help you do log aggregation and traces. Managed Prometheus for metrics. AWS Distro for Open Telemetry. We'll talk more about it, but this is for collection. And Grafana for visualization. So all 3 pillars of observability, that is logging, metrics, and traces, are covered by open source observability services available as a managed service on AWS. Okay, let's dive deep into each of these 4 services. The first one is Amazon Elasticsearch. Amazon Elasticsearch has been on the platform for many years, and many of our customers uses it for use cases like log aggregation. For example, Pinterest and Airbnb uses Amazon Elasticsearch for log aggregation at scale. There are a lot of things I can talk to you about Amazon Elasticsearch, but I picked 3 items to share today, which are very relevant for open source observability. The first one is log aggregation itself. Amazon Elasticsearch enable you to aggregate logs from wide variety of sources. It can be your EC2, it can be AWS services, it can be your VPC flow logs or whatnot. So this slide shows the architecture that you can have to aggregate logs. On the first part, we have producers, which I just talked to you about. And then we have collectors to collect data from these producers. That can be CloudWatch agent, a Kinesis agent, or any other agent you would like to have. Then these agents sends data to aggregators, which is Amazon Kinesis Firehose. You can use even S3 or Logstash. A very popular option is Logstash along with Elasticsearch and Kibana. These aggregator sends all your logs to Amazon Elasticsearch service, which you can visualize on dashboarding Kibana. Now, the second part which I want to talk to you about this service is how can you run Elasticsearch at a very large scale. Our customer told us that running Elasticsearch at scale is very expensive because the log volumes are growing every day. Retaining 30-day or more logs can be very costly. So over the last 1.5 years, there are a lot of innovation from Amazon Elasticsearch service. And one is the tiers, warm and cold tier for your logs. So you can have all the logs in the hot data node for the days like 7 to 14 days. And after 14 days, you can move them to a warm tier, which we call as ultra warm. And ultra warm tiers enables you to retain logs for a longer duration at up to 90% less cost. And we also introduced earlier this year a cold storage, which is basically just the storage without the compute. So even lower cost option to retain logs for a longer period of time. So in this example, what our customers are doing, I'm giving it as an example. They are retaining the first 7 days logs in hot data nodes, and then 15 to 30 days in warm, where you still can access the logs with the same Kibana query, same Elasticsearch query, and then after 30 days, our customers are moving logs to the cold storage for longer term retention. The third thing which I want to talk to you about Elasticsearch is tracing. Amazon Elasticsearch also offer trace analytics. What trace analytics? You can continue use the tracing frameworks which you're using today, like Jaeger and Zipkin. And you can send all of those traces uses open telemetry collector, and talk more about that later, to the data prepper to Elasticsearch service and visualize that on Kibana. For the visualization, there are 3 top features which I want to talk to you about. One is trace span. This shows you what is the lifespan of a trace. Second is the service map. Trace analytics with Amazon Elasticsearch automatically creates a service map with how your systems are connected. The last is the trace group, where you can group the similar traces to look at, like, for example, like what is happening to my login system, login processes. And you can club those into one group and look at how they are performing. So that's about Amazon Elasticsearch service. For log aggregation, you can do a lot of cost optimization with using the right tier and retain logs for a longer period of time, and traces using trace analytics. Now let's talk about the third pillar of observability, which is metrics. So now the next pillar for observability, which is metrics. Recently, we announced Amazon Managed Service for Prometheus. It is in preview, very soon going to be GA, and I'm going to talk to you about how Prometheus can help you aggregate metrics. And there are 3 things which I'm going to share. Let's dive right into it. So what is Prometheus? Prometheus is one of the most popular cloud native foundation, CNCF foundation project. It is being used by many customers for use cases like metrics from Kubernetes. Uh, as you can see, Prometheus is very popular in the community with over 150 plus exporters which can export the metrics to Prometheus. Um, Amazon Managed Prometheus makes it very simple for our customer to use Prometheus. To get started, all you need to do is create a workspace, have Prometheus ingest the metrics into that workspace, and visualize on a tools like Grafana. Let's dive a little bit more into it, that how all of this works. So you're going to have a Prometheus. You can continue to use Prometheus server, which you are using as of today. And you're going to send all your writes to Amazon Managed Prometheus as a remote write with the remote write URL. And your Prometheus server, your existing Prometheus server, start writing to the Amazon Managed Prometheus. And within Prometheus, there are two components, ingester and querier. Querier is actually which someone like Grafana going to talk to, and all the data is stored in Amazon S3. You can also use OpenTelemetry or AWS Distro for OpenTelemetry to send metrics to Amazon Managed Prometheus. That's about Prometheus. Let's move on to the next one for visualization, which is Grafana. Amazon Managed Grafana makes it very easy to visualize logs all at one place using open source software Grafana. What is Grafana? Is Grafana uniquely visualize and combine insights from multiple open source, cloud, and third-party data sources. It is one of the most popular visualizations tool in open source community. Why it is popular? Because the community has developed so much on it. AWS makes it even easier by offering the data sources on Grafana. You can have Amazon CloudWatch, Amazon X-Ray, Elasticsearch, or other system as a data source, sending data to your Grafana dashboard. You can also have plugins like MySQL, Graphite, or Postgres to fetch data and put it on the Grafana dashboard. Getting started on Amazon Managed Grafana is also very simple. All you need to do is to create a workspace. You can use AWS SSO, single sign-on, to create users to be used on Grafana. And without needing to have them access to AWS console, they can directly log into the Grafana and connect to all the data sources like Amazon Managed Prometheus or CloudWatch and start visualizing or creating dashboard. So let's look at how these dashboards look like. Here is the sample dashboard, which is showing the data coming from Amazon X-Ray, which is basically a native offering. So Grafana is using Amazon X-Ray as a data source and displaying the dashboard and the metrics from directly on the Grafana dashboard. Now, that's about Grafana. Let's move on to the next section and talk about AWS Distro for OpenTelemetry. Now, OpenTelemetry is here. I'm going to talk to you about three things. What is OpenTelemetry? Why AWS Distro? And the architecture. What is OpenTelemetry? OpenTelemetry is one of the most popular CNCF projects out there right now. What is why we need something like an OpenTelemetry is, if you see 50% of the companies use at least 5 observability tools, and 33% of those companies use more than 10. So data is being gathered and aggregated in multiple places. OpenTelemetry is an attempt to solve that problem and bring standardization and for data collection. You can have it has traces, metrics. You can have standardization in collecting traces, metrics, and logs. It is also vendor neutral. You can collect it in a standardized way and you can ship it to the destination of your choice, whether it's Amazon Elasticsearch service or Prometheus, a self-managed Prometheus, or Amazon managed Prometheus. AWS Distro for OpenTelemetry is downstream distribution of OpenTelemetry as is, with making sure that it is ready for our customer to be used. It's backed by AWS. It is well tested, and to make sure you can actually use OpenTelemetry without worrying about support and testing and validation. So let's look at the architecture. How does AWS Distro for OpenTelemetry work? So you're going to have application code, and OpenTelemetry API and SDK sends all the data through the exporter to these backend services like X-Ray, CloudWatch Metrics, Prometheus. And these OpenTelemetry collectors actually work as a translator and convert the format, whatever the format the source is generating, into the format what destination is expecting. So that's about OpenTelemetry. Now let's put all of this together. To put all of this together and see how can we have a holistic architecture with Prometheus, Grafana, OpenTelemetry collectors, and Amazon Elasticsearch for observability solutions. In this slide, I'm showing you how you can put all of these 4 services together and achieve a single pane of glass for all of your needs, observability needs like logging, tracing, and metrics. So in this architecture, you have applications running on Kubernetes or EC2 instances, and OpenTelemetry collectors is collecting data from those applications, collecting metrics, sending it to Prometheus server. Prometheus server is storing all those metrics into Amazon managed Prometheus with the remote write we talked about. Amazon Elasticsearch service is gathering all the logs and traces from your applications using Jaeger and Zipkin, traces using Jaeger and Zipkin, and log using our collectors and aggregators we talked about. You can use Kibana to visualize all the logs and traces. Amazon CloudWatch you can also have Amazon CloudWatch logs sent to Amazon Elasticsearch service using AWS Online. This is optional. Because in Grafana, you can have a CloudWatch as a data source. But if you want all your logs to be at one place, you can ship CloudWatch logs using AWS Lambda to Elasticsearch service. And you can also export all the metrics coming out from Amazon managed services like RDS and Elastic Cache using Prometheus exporter for CloudWatch and send it to the Prometheus. So now all the metrics from your application from EC2 is going to Prometheus. You can also have the managed services send the metrics to Prometheus using exporter. You can have Amazon Elasticsearch get all the logs from your applications and EC2 machines. And all of this can be visualized at a single place, which is Grafana. Grafana can have a data source of Amazon Managed Prometheus, CloudWatch, and Elasticsearch service. So that's pretty much how you can bring all these 4 open source managed services from our AWS in one architecture and achieve single pane of glass for your metrics, logging, and traces. So today we talked about AWS Elasticsearch for logging and traces, and the tiering for AWS Elasticsearch, where you can cut down your cost and achieve longer term retention of your logs. We also talked about Prometheus and how Amazon managed Prometheus, making it very easy to run Prometheus at a scale by keeping your Prometheus server and sending all the writes to Amazon managed Prometheus. We talked about Amazon managed Grafana, how it make it simple for anyone to visualize data from different data sources like CloudWatch or Amazon Managed Prometheus. We also talked about AWS Distro for OpenTelemetry, which is bringing the standard a well-tested package ready for you to be used to bring standard into your collection of the data, and then shipping it to the right data source like Prometheus or the data source of your choice. So let's move to the next section of this talk, which is even more exciting, where we're going to talk to one of our customers, Airbnb. And it is my pleasure to have Saurabh Mehta from Airbnb. Let's get right into it and hear directly from him.
Hi, everyone. Thank you, Amulya, for introducing me. I'm really excited to be here and being part of this conversation. So, my name is Saurabh. I work for Airbnb. I'm this engineering manager for reliability engineering and focused on the observability area, part of that organization.
Thank you, Saurabh. I'm equally excited to have this discussion with you. So when I was talking to you earlier, we named this talk as a Oli chat. So what this O11Y is, can you tell us what is this O11Y? Sometimes I get confused why we are calling observability as O11Y.
Well, it's a great question. So I guess we are in the era of Twitter, so everything is being shortened to keep it crisp and sweet. So I think it's just a trend that industry caught up to actually pick up the first and the last letter and shorten it to call it like O11Y, such as K8s and such as A11Y, which is accessibility. So it's just that I'm just talking about the part of how the definition came from, but of course observability is far more beyond that. Traditionally, folks probably think of this as the computing industry started to evolve, and some of those things probably you touched in your presentation. So started with the tail miner of the logs where we were with the monolith, and going from that to a distributed and microservice environment, and collecting far more complex signals, and how we can actually bring that together. So observability, in my opinion, is not just collecting the data or looking at just the data in a disjoint format. It's the combination of things coming together and draw the more value out of it. I think you can compare it with a human and a robot, which is a machine, which as you start to get having problems, your body starts emitting some symptoms, and you read those symptoms and you deduce something is wrong with your body. It's the same thing with a machine. When it starts to go wrong, and it starts to emit some symptoms, and those symptoms are the signals from the observability that we collect, and then bring that together in really to understand what's the problem is, to reduce the problem. And as more and more businesses started to go online with the recent push of COVID, there are more and more businesses start to get online. So it's becoming such a critical part of the business operations in order for you to know how your business is running. In my opinion, it's another critical pillar of infrastructure, along with compute, storage, and network, which is very essential for you to run your business and then and run it really efficiently, so you're serving your customer with your best interest.
That's great. That's great. So let's get into the next question. I'm curious. Tell me more about your role and your team charter at Airbnb.
Great.
What do you mean by reliability engineering, and what your team actually charter is?
Certainly. So reliability engineering and in some other areas called as production engineering as well, is basically you can think of as a field of generalist. And I'm picking this from my from my manager as he described itself, because you have a specialist and generalist roles in this field. And by what I meant by generalist is you know the breadth and the depth of the infrastructure and product, and you are working to protect you're working to provide the best reliable experience for your customers, and it can be for any business. So that's what the role of the reliability engineering at Airbnb is to provide and protect the best customer experience for our guest and host, and we sit at the cross section of product and infrastructure, and they're a team of awesome engineers and comprised of like observability, SRE, incident management, and QA, which come together to run this charter in order to make this happen for our company. And particularly my talking about observability role. So observability, certainly, as I mentioned, it's actually provides the platform and services for various different signals that we want to collect from our product infrastructure to ensure things are running fine. So we observability team manages these distributed platforms and operate them at scale, be it the logging platform, be it the metrics platform, be it the tracing platform, and some of the other subset of the systems that we run in order to provide that complete experience.
That's great. And so your team charter is basically providing, if I understand correctly, all the observability tools which are consumed by all your platform developers across Airbnb.
Certainly, and actually, I would probably add a bit more to that. As I said, so observability is not just about the collection of the data. Our mission is to make observability as a standard practice and reliability as a standard practice for operating and running services and products across Airbnb. So we also provide best practices. We ensure that the observability data is collected in a and the signals that matters which are collected, and they're collected in a reliable fashion, and they are available. And then on top of that, how to bring the cohesiveness within these signals in order to draw the maximum value out of it. So we definitely go beyond collection of the data, and we practice this as a field, and establish this as a standard practice within Airbnb.
Actually, that's very rightly said, right? Because if you cannot measure it, you cannot improve it.
That's
And
100%
I
right.
think you rightly said, building a practice, building a discipline across the company that this is important and this is something everybody needs to do is the right way to do it. So that's a beautiful insight. So moving on, tell us more about the observability stack you run. Tell us about what does the observability stack look like, what your team manages.
So certainly happy to touch on that topic. And like any other company, we have standard observability pipelines, whether it's starting with the logs as anyone starts, and collecting the structured and unstructured logs. And that's one of the platform pipeline that we operate. And as you know, like we use Amazon Managed Elasticsearch for that, and it works out great for us. Provides us the flexibility in order to like how much you want to scale and scale down the services when we need it, and providing like long-term storage and whatnot. So that's talking about the logs part. And we have a metrics and APM tracing pipeline that we manage, and that provides another observability signal and the data that we need for our monitoring and alerting. We also have error and service tracking, which is we have like our own internal pipeline. We run Druid for that, and then we have a tooling on top of it to provide that experience in order for like as Airbnb transitioned from monolith to microservices environment. This was very essential for us to have it there, so that we can really know what's going on with our services, and we can really understand the errors and other aspects of the services in order to run that efficiently in production.
Yeah, so at Airbnb scale, I'm pretty sure the log scale must be way higher than like any smaller company, because you're a web platform used by millions of people around the world. So how are you able to manage your retention and cost? Was there anything like, were you give me more about how you, like, for the benefit of the audience, like any guidance on what is the hot data and the warm? Were you using those architecture or?
Certainly, as I mentioned, so we use AWS Elasticsearch for our logging platform, and coincidentally, it provides us so much flexibility. And last year was really tough for overall, and our focus changed quite a bit. And we spent a lot of time optimizing and making our services run efficiently. And the one of the things that we did was to ensure that the logs that we need, we are only keeping it for only for that much of retention. And we in fact work with you folks to do the POC for ultra warm tier, and that was very helpful for us to keep the certain amount of data in the hot tier which we need, and ship off all the other data to the ultra warm tier, so that because you don't need everything at the right moment, like because if you are debugging any incident in production, you probably need like last 24 hours worth of data, but you don't need like 10 days before
that's a
that
very
data.
good point, Saurabh. And that was my next question. That 2022 was a tough year. 2020 was a tough year for travel industry. I am curious how it impacted your team priorities. What were you working on before, and how you pivoted to the challenges which pandemic presented on the travel industry? So,
Certainly. No, thanks for bringing that up. Certainly, it was a challenging year for us as well as for a lot of others. And observability, to be specific, I think this was our goal anyways, to run our services efficiently and provide the maximum value out of it. Actually, pandemic sort of like pushed us in that direction more, and it helped us to be more focused on doing smaller number of things and doing it more effectively, rather than like doing many things in running in parallel. So we did a lot of optimization on the observability stack itself, as I was describing earlier, controlling the cost for the logs and few of other pipelines. But observability also provided insights across the company in order for other optimizations and performance efficiency gains, because we collect the machine data, we collect all the CPU memory data, and that provides key insights, how can we optimize or where can we optimize. So observability played a very key role, and in general it was a great to see like how people came together and put the focus in these efforts, and then we working together as a one company to drive that efficiency and performance gains. So I think this was a right it was a blessing in disguise, I would say, which helped us to put our focus on a smaller number of things and operate efficiently.
no, as you rightly said, I think having the discipline to collect the right data, I think I'm repeating what you said earlier, across the company, the data that matters, and use that to drive optimization is very futuristic or very cloud native way of running things. And the example which you gave is amazing, that how it helped reducing the cost or optimizing the architecture at the time in the time of the need, when travel industry actually was looking for cost optimization last year.
Certainly.
Okay, so moving along, for the benefit of our audience, I would like to ask you, what are some of the challenges and opportunities you see in the observability space, specifically around open source observability, which we are talking about today?
No, certainly, great topic, and I think as this industry has been evolving at a breakneck speed, and a lot of things are moving, and new technologies and tools coming. So there are a lot of challenges that those tools are solving, and then creating more opportunities for us to leverage them. In my opinion, you can broadly categorize the challenges in 4 different areas. Starting with the data collection, we have various ways to collect the data. I think you mentioned this in your talk, like in terms of like how many collectors we run on our nodes. It's like mind-boggling. So in terms of like collecting the various different signals, and it's just because of the various different standards. So there are multiple challenges in terms of the data collection. I also want to touch base on the other challenges that are related to data collection, is dealing with legacy code bases. So this problem comes when a company matures and you want to add the observability after the fact, and it's a mountainous task to actually go back and instrument your older code base, legacy code bases, to collect the signals. And sometimes these legacy code bases are running very critical part of your function, and you want to ensure that you have the right observability for that critical function, and it poses a unique kind of challenges for certain companies, and mostly large scale companies, because you don't have like that much of a bandwidth and hygiene to go back and do it. And touching on the data storage, also we have various different disjoint storage systems today, if you think of, uh, which is which is done because of the optimization and efficiency that it provides for different signal set. I'm talking about like time series database versus the columnar storage versus the log storage and whatnot, not right? So, but it does creates a unique kind of challenge to have a how do you actually bring these signals together, and how do you efficiently query them from various disjoint data sources. Speaking of data access, it's very much tied to the data storage. We lack a unified query language that can again combine these together. And how do you actually bring them together? Even within certain, even if I talk about just the metrics, there are different query languages that are floating around. Whereas I see that as an opportunity, and that's one thing industry is catching on to actually standardize on the input and output side of the data. And then last but not the least, the most important part is the insights. uh, that is also tied again, like, I mean, as you collect all this observability data, how do you make sense of it, and how you could draw the actionable insights from it, because that's the greatest purpose that you need to serve from after collecting this data. So now I spoke about the challenges. I want to touch base on the opportunities there. uh, Talking about data collection, I think there's a lot more community engagement or drive that is happening to align towards open standards and open source. Open telemetry is being one of that, to see like how can we actually have like all the observability signals being collected by one collector, and have the one standards that can be work across the technologies and across the companies. So that's one of the opportunity that I see and very excited about. There is also evolution of the multi-model storages, but we're still not there. I think this is still there are still some challenges that is being posed by different type of data. Speaking about particularly on the metric side, if you're dealing with a large set of cardinalities, large set of dimension tag values, you always have a problem of challenge to keep it in a one efficient storage, compared to, like, I mean, other columnar store where you can actually keep like a large number of dimensionality. So there is definitely some evolution there, but I think there is some opportunities that are still like probably going to be coming in the future as this field evolve and more. And then as I mentioned about the unified data access and query language, this is something it's probably at least uh, I see this is happening at least for metrics. I think I see this is happening for logs and traces. At least I see Elasticsearch query language coming together as a one way to access this data and to provide the access to the data. So which is great. So which probably want to see more of that, and to see like how can we have less of a defragmentation and more of the correlation with the other on these signals. And then last not the least, to draw the actionable insights, there's a huge opportunities to reduce the signal to noise ratio, because you actually set up a lot of the alerts on these data set, and but sometimes often they are very noisy, and you probably lack the correlation between the different signal sets. So if you have an opportunity to correlate them together, they can bring more actionable insights, sort of like developing an inference engine or correlation engine which can bring all the data signals together and run them together. Yeah, I think I went way too fast.
No, it's great. It's great. So correlation is very important. I think you very rightly touched upon that. You have metrics, three different pillars. You have metrics coming in, you have logs coming in, and you have traces. How can you correlate all of that on the same time? Like what my logs are telling me? I think that is very important. And I think it is still evolving. It is still evolving. Do you think efforts like open telemetry gonna help the correlation and bringing the standard into this space?
I certainly am excited about that. I definitely see that we have a need. And one thing, probably just from my own side, is I think if we go back to the pre-cloud era, different companies were doing things differently because they had a different infrastructure stack, mostly private clouds. If we talk about like big giants at that point of time, so there wasn't any need for standardization. what cloud did is to push towards standards and to have like more and more adoption of the public cloud. So there is a natural push for having this standardization. Otherwise, it becomes a hell to operate and interoperate. So I think this is just a natural evolution that is happening, and it's bound to happen in order for us to be coming to the same standards and reaching towards like so that you can interoperate into various different ecosystems. So I certainly see there's a lot more value that it will bring, and there is a high time and high need for it that we need to have this standardization.
Yeah, so thank you. That's very insightful. Yeah, I totally agree with you. That's why at AWS also we are very, very, very engaged with Open Telemetry initiative, and some of our principal technologists and principal engineers are constantly working, driving it forward, pushing it forward. So very excited, that the work which AWS is contributing and the overall community is doing on this space. Okay, so the next part I have sort of for you is what are the trends you see in observability space? Like what you think is changing or can change or need improvement? What are the trends?
No, that's a great question, and I think some of these were already touched in our talk. So I think one of the main trend is the open source and open standards becoming mainstream. Earlier, it was like probably not at this pace. At least I've been in this industry, in this area, or focus area, or in the industry for like at least 7-8 years, and I haven't seen that much of a traction towards open standards and open source as in the last couple of years, because there is a huge push as more and more movement is happening to the public cloud space. There is a more need that is driving it, and more people needing that observability, and the need for that is increasing. The another interesting thing that probably we will see is logging is a sort of underrated area, in my opinion, and I think there's just far more insights that can be driven from the logs. We will see index-free log aggregations getting more and more traction, because logging is something that any machine or anything is generates. Is forgiven. You don't have to put like any effort towards that. But how do you draw more and more insights from it? As you will see, like there will be more of like dissecting the logs at the source or on the fly to draw the more insights from that, and then figuring out like bringing that as a signal to either to the alerting or correlation with that signal of the data. More standardization of the technologies on the input and output, as we are seeing PromQL becoming de facto for a lot of the time series databases, and on the output side and the input side, the open telemetry standards and other standards evolving. So there will be more of the standardization. I think there's a lot more focus on the input side. Output side is still lagging behind. So I definitely see there will be a more area of like bringing these signals together under common query language, or at least to have like some way of easy accessing this data together through one query language. And last but not least, like, so observability is not just collection of the data. So there will be, I think traditionally it has been that data is there, you go and debug the signals, and you figure out the problem. I think there will be more and more of correlation and drawing the actionable insights. So there will be more that field is probably untouched, apart from some maybe some bigger companies doing something on their own to draw the actionable insight, doing more machine learning and deep learning kind of things. But I think this would also become commonplace in the coming years. So more value that can be drawn from this data.
Yeah, so that's very interesting. So I wanted to ask like the AIML usage in this space. So there are few things which AWS is working on. There's an anomaly detection in our Elasticsearch service, and there's pretty much any data gathering service, even like CloudTrail or CloudWatch. There is an anomaly detection coming up in all of those spaces. Do you see more of that going forward, like rather than we as an observability engineers or as an SRE to put alerts and trends? Do you see the AIML going to start doing more of that alerting?
Well, automation is the key for everything. And I think more and more we automate and leverage this data in an automated fashion and self remediation loops. That's the future. Uh, you have to give it to the machines to handle the machines itself. So I believe like there will be more of a becoming that as a commonplace, because today if you are if you're just starting with observability, you will traditionally start with spinning up your logging stack and putting a metric stack, and then you'll be just going to that and then looking at the things, or probably set up alerts and whatnot, right? So I think the more of like observability stack as a complete stack coming together with all the bells and whistles, and then on top of that having like these intelligent layers which could help you to detect the problem and have an integration into your different pipelines, whether it's a deploy pipeline, whether it's your creation pipeline, or it will go in that direction so that it can cover the prevention, detection, and remediation with automation, like the complete phase of like your life cycle for any product.
Yeah, that's very interesting. And I also wanted to reiterate some of the things which you mentioned earlier, is that the importance of open source, within, if you look at the AWS announcement from last 1.5 year, from just Elasticsearch as a managed service, now we have four, Prometheus, Grafana, and AWS Distro for open telemetry, all have been added in last 1 year. So it's certainly, the customers are asking for open source options, and the AWS is very, very active and working towards bringing the right tool for the right job on all of these metrics and logging use cases. Okay, so the next one I have for you and is that, what is the advice you have for all the observability engineers and observability leaders watching this today?
Well, that's I would say advice. I think I can share my experiences, or those are probably learnings. I'm still learning. This field is vast and very interesting. So I'm definitely excited about more learning opportunities. But I can definitely share some of the experiences that, or the mistakes that we observed and probably should not do. One of the common policies that our use case is special, and people start reinventing the wheel in terms of writing their own storage systems and creating their own stack. I think that's a very common policy to fall for. I mean, I believe there is a more standardization and there is a more things that open source can handle at scale. Having gone through this experience myself, we I the one of the thing that you can prevent doing is like, do not reinvent the wheel. Try to adopt the open source and try to be part of the community. It not only helps you in a tremendous way, but also advance the field. So that's one thing I have learned in so far in my career. Another thing is, do not mix the business and operational data together. This is could be just my own experience, may not be happening everywhere, but I think that's another thing, because the technology stack sometimes aligns. And why I'm saying this is because there is a the systems are optimized for different needs for business versus the operational monitoring. Uh, Going by traditional gap theorem, is like consistency and availability versus the consistency and partition tolerance. So you need to have like a distinct systems for different type of data. So that's one of the other thing. And then do not get into the business of writing clients for everything. That's another thing, because there is already a community supported client, and it becomes really challenging over the time to manage the clients across different programming languages and different evolutions of the product. It's a huge workload that you will basically bring uh, into your ecosystem, and it will become a challenge over the time. So that's just few like very high level learnings that I have observed in my career so far. But in general, I think it's a great field for anyone to learn a lot more about the product and infrastructure components. It's a great. There's a lot more challenges that are sitting to be solved. So it's pretty great to be like working in this area.
No, thank you very much, Saurabh. That was actually very insightful, and I can totally relate to that because what you said, that don't try to overfit a solution on some other problem. Like I really liked when you said the business and operational data, keep it separate, processes separate, and AWS is the same philosophy. Right tool for the right job. If you look at our database offering, it's there are multiple databases offering like graph to NoSQL to in memory to relational. In observability space as well, we have CloudWatch, X-Ray, Container Insight, and then we have Prometheus and Grafana. So what you said is can totally resonate with our philosophy as well, that don't try to overfit, use the right tool, because I think you rightly said cap theorem, right? You can only optimize on a use case with our tool. You cannot have like one size fits all. So that is
Certainly.
very, very good to hear. So thank you very much, Saurabh, for joining us today and talking to us about observability, especially open source observability. As always, you've been very valuable customer, and thank you for all the partnership and support.
Oh, thank you for having me. I mean, this is great. Really, really excited about this space, and good to have a chat.
Yeah, thanks for sharing all the wisdom. Like really appreciate. It was a great discussion.